Okay, so to continue example 6, again we are given here two lines, 4x minus 7 and 2x plus 3y minus 21 equals 0. So our business here, our task here is to find the coordinates of points A, because we already have the coordinate of point B, the coordinates of point B. Okay, so we already have B equals negative 2, 8. So we need the coordinates of point A so that we can use the 2-point form the equation of the line. Okay. Now for the second line, 2x plus 3y minus 21 equals 0. This gives us 2x plus 3 times 4x minus 7 minus 21 equals 0. Now we are solving for the coordinates, so we are looking for the value of x and y at A. So now, since y is equal to 4x minus 7, I just substitute this here. Okay, so substitute it here. So we get 2x plus 3 times 4x minus 7 minus 21. So to simplify, we get 2x, 3 times 4x, we get 12x. 3 times negative 7, we get negative 21 minus 21 equals 0. So to simplify, this is 2x plus 4x is 14x, negative 21 minus negative 21 is negative 42, this one is negative 42. Then put this to the other side, we get positive 42. Then we divide both sides by 14 so that ux is equal to 3. Okay, so we now have the x coordinate of point A, where this A is the intersection of your two lines, y equals 4x minus 7 and 2x plus 3y minus 21 equals 0. Let us now solve for y. From the first line, y is 4x minus 7. So when x is equal to 3, that gives us 4 times 3, which is 12 minus 7, and this is 5. Okay, so this point x equals 3 and y equals 5 are the coordinates of point A. So we now have the point A with coordinates 3, 5, and point B with coordinates negative 2, 8. And this is negative 2, 8 again is given. So using 2-point form of the equation of the line, we get y minus y sub 1, which is y minus 5, y sub 2 minus y sub 1. This is 8 minus 5 equals x minus x sub 1, that's x minus 3. Y sub x sub 2 minus x sub 1, that's negative 2 minus negative 3. Simplify, we get 8 minus 5, this one is just 3. Negative 2 minus 3 is negative 5, and then we multiply negative 5 this side, and we multiply 3 to this side, so that we get negative 5 times y minus 5 equals 3 times x minus 3. So if we simplify, this is negative 5y plus 25 equals 3x minus 9. And finally, the standard form, or the general form of the equation of the line is 3x. Put negative 5y to the other side, it becomes 5y. Then we have negative 9 minus 25 is negative 34 equals 0. So this is now the required equation of the line. The required equation of the line is written in the form as mentioned in the problem, ax plus by plus c equals 0. So a here is 3, b is 5, c is negative 34. Okay, they are all integers. Okay, now exercise 5D is found on page 83. So if you take a look at it's page 83 of your workbook, you have there exercise 5D. So just practice all these problems here, and once you have your answers, check it at the back of your lecture notes. Yeah, you get the answer. You have the answers here. Okay, let's continue. Now, when can we say the two lines are perpendicular? If your first line has gradient m sub 1 and your second line has gradient m sub 2, We say that they are perpendicular if the gradient of the second line is equal to -1 divided by the gradient of the first line. This relationship says the gradient of the second line is equal to the negative reciprocal of the gradient of the first line. Okay, in other words, we say that two lines are perpendicular if the product of their gradients is -1. So if you multiply here m sub 2 times m sub 1, you should get -1. Okay? So they are negative reciprocals of each other. So you take the product. This is true only for perpendicular lines. So we say the two lines are perpendicular only if the product of their gradients is equal to -1. Okay, so let's take a look at the first example, example 6. Let us work out the gradient of the line that is perpendicular to the lines with these gradients. So A is 3, B is 1/2, C is -2/5. So for 3, if M1 is equal to 3, then M2 is just -1 over M1. This is the formula since they are perpendicular. So we just substitute. This would be the gradient for M2. So the line with gradient equal to 3 is perpendicular to the line with gradient equal to -1/3. Now if the gradient of the first line is 1/2, then the gradient of the second line perpendicular to this line should be -1 over 1/2, which is equal to, you take the reciprocal, that is equal to -2. So m equals 1/2 is perpendicular to the line with m equals -2. Okay, last example. If c is equal to -2/5, on the other hand, same formula we use. M sub 2 will be -1 over M1, which is equal to -1 over -2/5, which is negative divided by negative. This one is positive 5/2. Okay. Example 7. Let us show that the line y equals 3x plus 4 is perpendicular to the line x plus 3y minus 3 equals 0. So we are now given two lines, y equals 3x plus 4 and x plus 3y minus 3 equals 0. We are going to show that they are perpendicular. Now, perpendicular meaning if this is your line 1 with slope m1, if this is your line 2 with slope m2, then the product of their gradient should be equal to -1. Okay. Now for the first line, y is equal to 3x plus 4. So because this is already in gradient intensive form, we have 3 equals your m1. So the gradient of the first line is equal to 3. Now for the second line, this is written in general form. So to find the gradient of this line, let us transform this one first into the standard form. So what we do? So we get 3y equals, put x to the other side, it becomes -x, -3 to the other side becomes +3. Make the numerical coefficient of y equal to 1 by dividing both sides by 3. We get y equals -1/3 x plus -1. Now, for the second line, we're able to transform it into the standard form. So this is y equals mx plus c, which implies that your m for the second line, or m sub 2, is -1/3. Now to check that these two lines are perpendicular, okay, as required in the example, in the problem, let us now take the product of the gradient of the first line and the gradient of the second line. So what do we have? We get m sub 1 times m sub 2. We get 3 times -1/3. This is cancelled, so we get -1. Okay? So the product of the gradient of the first line and the gradient of the second line is equal to -1. Therefore, we say that the two lines are perpendicular. Okay, so this is always the requirement. If you find that their product, the product of their gradients is equal to -1, automatically they are perpendicular. Okay, let's take a look at the next example, example A. By the way, your worksheet for this particular chapter will be posted after the video, so you just try to answer that one, and yeah, if you have any questions, please just comment below. Okay. Now, example 8. This is found on page 86. Let us find an equation of the line that passes through the point 3, -1 and is perpendicular to the line y equals 2x minus 4. Now, here we are given a line which is perpendicular to the required line and a point where that required line passes through. Okay. So we have the point 3, -1 and we have the line y equals 2x minus 4. Now, for the first line, y equals 2x minus 4, as this is in standard form, this gives us our m equals to 2. This is the gradient of your first line. Now, since this first line is perpendicular, okay, it's perpendicular to the required line, the gradient of the required line should be the negative reciprocal of the gradient of the first line. So that gives us the gradient of the second line equal to -1/2. Okay. So we have the gradient, we have a point. So this we can use now the gradient point form of the equation with the line. So we get y minus y sub 1 equals m times x minus x sub 1. So you just plug in these points here, m being -1/2, y sub 1 being -1, and x sub 1 equal to 3. So simplify. Let us free this from fraction. We'll multiply both sides by 2. We get y times the negative that gives us +1. So that gives us 2y plus 2. -1 times x, -1 times -3, that gives us +3. Now, in this particular example, it does not say that we should write our equation in standard or general. So it's up to you now which way you want to write your equation. So standard or general, it doesn't matter. So in this particular case, let us just write this one in general form. If you put -x to the other side, it becomes +x plus 2y. Then you have 2 minus 3, that gives you -1. So this is now the required equation of the line. So the equation of the line that passes through the point 3, -1, and which is perpendicular to the line y equals 2x minus 4 is x plus 2y minus 1 equals 0. Okay? Now, if you take a look at page 86 of your workbook, you have there exercise 5E. So try to solve some of these exercises here and check your answers at the back of the workbook. You have your answers there at the back. And then if you have any questions, please don't hesitate to comment below. Whatever you want me to clarify on. Okay, for your first assignment, now for this particular chapter, this will be your assignment. I will be posting also these questions in Google Classroom under the assignment, under the classwork. Okay, so you can find all these questions under classwork. Your task to answer mixed exercise 5F. So mixed exercise 5F is on page 86 to 87. Please answer question 1, question 3, question 5, and question 10. Okay. So 1, 3, 5, and 10. I will be the instructions on how to submit your assignments is in your Google Classroom. Please don't forget to check from time to time what is written there. Okay. So thank you very much and have a good day everyone. Keep safe. Next time, I will be dealing with polynomials. That will be for week 9. So if you have questions for this chapter, then please don't hesitate to ask. Okay? Bye bye.